Hello, and welcome to the Data Engineering Podcast, the show about modern data management. Introducing RudderStack Profiles. RudderStack Profiles takes the SAS guesswork and SQL grunt work out of building complete customer profiles so you can quickly ship actionable, enriched data to every downstream team. You specify the customer traits, then Profiles runs the joins and computations for you to create complete customer profiles. Get all of the details and try the new product today at dataengineeringpodcast.com/rudderstack. You shouldn't have to throw away the database to build with fast-changing data. You should be able to keep the familiarity of SQL and the proven architecture of cloud warehouses, but swap the decades-old batch computation model for an efficient incremental engine to get complex queries that are always up to date. With Materialize, you can. It's the only true SQL streaming database built from the ground up to meet the needs of modern data products. Whether it's real-time dashboarding and analytics, personalization and segmentation, or automation and alerting, Materialize gives you the ability to work with fresh, correct, and scalable results, all in a familiar SQL interface. Go to dataengineeringpodcast.com/materialize today to get 2 weeks free.
You're trying to build stuff and use the data.
And now, bringing us to the Anomstack project, you said that some of its origin comes from the work that you're doing at NetData, but I'm wondering if you can just give an overview about what it is that you've built, some of the story behind how it came to be, and why you decided that you wanted to make it as accessible and approachable as possible.
Yeah, so probably primarily it's because I've had to build versions of this in every job I've been in for the last 10 years, and it's always been kind of custom every time and a little bit, not very very custom and specific to whatever infrastructure or data stack you're using. But nowadays, there's a lot of open source projects and tools that we can build on, and I just felt like the time is right now to actually save myself from building it the next time for the next 5 years. Actually just build a project that I can kind of open source and see if I can get some contributions around. And so the idea there is this is focusing on a smaller team, smaller data operations. Give them a simple way to just bring their metrics and get really decent anomaly detection out of the box, basically.
And in terms of the term metrics, given your background in NetData, that makes me think about metrics from an operations and infrastructure standpoint about what is the CPU load, what is the available memory. But the term metrics in the data ecosystem has also become overloaded with this idea of the semantic layer and business metrics and what does it mean for somebody to be a customer. And I'm wondering if you can maybe give some sense about how you're thinking about metrics in the context of Anomstack and the ways that it can be applied.
Yeah, so actually, metric trees is another thing I've seen recently. There's a lot of talk around metric trees and building these relationships onto metrics. Their main goal is simplicity, and so there is lots of different metric concepts in the observability space. But we're not using that here necessarily. So the definition of a metric basically is a row in your data frame or a row in your database in the metrics table, where it's literally just a metric name, timestamp, and value, and that's it. So that's kind of the idea there. Is this makes it really easy for users. That's all a user has to produce is these three fields, and so we're not going too fancy in terms of like a complex metrics definition, because that just adds kind of a little bit more of a ramp for people to actually to use the system. So there's pros and cons to each, of course. Like in observability, and you have all these concepts in tools like Prometheus, and the different types of metrics, and how you work dimensions in and stuff like that. But for our case, for an Anomstack, the idea is just keep it as simple as possible, basically, to begin with.
And that also makes it very flexible because if you don't necessarily have a constrained definition of what that metric can be and what it's supposed to mean, then that means that everybody can map it to whatever semantic attribute they want it to in order to determine what are the anomalies and how does that impact whatever it is that I'm trying to measure.
Yeah, and this is kind of actually something that I have got on the roadmap for the project, is to extend a little bit so that when you're defining the metric, you also define some metadata. Obviously, the first thing being like a metric description, say, and the idea there is actually if we could do that, even if you had a useful description, that would help a lot more with then like the saliency of the anomalies, because an anomaly is an anomaly, but whether it's something you care about or not is a different question. And so if we can get some of this metadata, like maybe things like priority P1, P2, or whatever different tags you want, you could obviously then do different kind of route. You can route alerts differently. But actually, like longer term, I'm thinking that there could be something where this could be something that large language models could obviously use as well. So if they had this kind of rich metadata that they could make sense of, that could also be useful in terms of, you might say, oh, what's my anomalies in the sales today? And like the fact that you have all this stuff in the descriptions would make that a lot easier. So previously with all the semantic stuff was good, but there's a lot of overhead to maintain it. You have to, agree on your structure up front and implement it. Whereas if we just allow some kind of free texty, more higher level stuff, there's definitely roles where I think language models could help make sense of it as well in terms of, sorting through the metrics.
Yeah, and giving you some human level understanding about, is this something that you actually care about?
Yeah, that's always the problem because oftentimes systems like this, you end up metrics, there's thousands of metrics, and the idea is, we want metrics to just be like cattle. You don't have to think about them; they're not special. Just produce your metrics, and then that's great because then you have all these metrics. But then the problem can be, how do you make sense of it when you have 100 alerts a day, and maybe 50 of those alerts are on metrics that they're nice to know, but they're not that important. So it's things like that where if you could have each of these alerts be like a little insight snippet, you could actually maybe have a language model make sense of it. Or ultimately, longer term, if you had a sort of a feedback loop on top of the system, like an Anomstack, where you could give thumbs up, thumbs down to sort of try and start measuring saliency of like, okay, well, what do people care about more than average? That then kind of could become a whole different layer on top of it. But it's that's an open problem. I don't think anyone's really solved that yet, to be honest.
Absolutely. And also, even if some single metric is anomalous, it maybe doesn't matter unless it's correlated with another anomaly in a different metric. And it's that conjunction of anomalies across different metric series, or maybe even across different service boundaries, that will let you know, oh, hey, there's actually something really wrong here. You need to do something about it.
Yeah, and that's like another, that's something that I've seen some people do really well. So Anodot is another tool I've used in the past for anomaly detection, and they do a really good job of this, where they stack all the alerts together into sort of, so each alert becomes like a stack of alerts, and then you can kind of really quickly see based on the map of like, okay, what's making up this batch of alerts basically. That's something that I would be like to add in the future as well. Actually, could be really interesting.
And you mentioned that one of your objectives of building this project and releasing it as open source is so that you don't have to build it again in whatever future role you have. I'm wondering if you can just give an overview about what are the core objectives that you have, and what are the things that you would like to see come out of this project, and some of the direction that you'd like to see it taken in.
Yeah, so the main objective is just have a nice, easy, open source solution for people to get good anomaly detection on typically business metrics is what I have in my head here, and low overhead, and then so if you're like someone that's kind of you don't necessarily have to be an infrastructure engineer. You just technical enough to maybe you bring your own SQL to define the metrics, or you can define custom Python functions to define the metrics as well. But the idea is like you could be a business analyst who could actually just bring your metrics and then actually stand this up yourself. It's just a Docker container. So that's the main idea, is like keep it as easy as possible for like smaller teams who either can't afford bigger expensive SaaS solutions, or they don't necessarily have the time or expertise to like build their own custom solution, to actually just use a tool like this and get decent enough anomaly detection on all your metrics out of the box. That's the main aim.
And for people who are interested in being able to get these alerts and understand, okay, I've got lots of metrics, I don't want to have to care about them and keep a close eye on them, I just want something to let me know when there are things going wrong. What are some of the other tools or products that they might be evaluating when they come across a Anomstack, and what are the aspects of a Anomstack that might sway them in its favor?
Yeah, so there's lots of there's kind of there's a couple of different solutions here, a couple of different approaches. There's like vendors who I've actually used in the past. Anodot is probably the biggest and oldest player here. Like they really good anomaly detection across all types of metrics, and lots of other stuff. It was a few years ago and I used them, and they've done a lot since as well. And so these are like services that you pay for in an enterprise setting, that they're are a bit expensive, and there's a bit of configuration involved. Once they're up and running, they're good. And then there's also lots of like newer SaaS type startups in the kind of modern data stack space and era that we're in. So Chaos Genius is another one there that's actually I've been looking at recently. That's pretty good and pretty cool. But there's also then the other approach there. A lot of the data warehouses now are starting to build some of these ML features into their stack themselves. So like Snowflake, BigQuery, they all actually now typically have their own anomaly detection functions and ML, like ML functions that you can train models and save models just within your SQL. So like that's another option as well. If you're using a platform like this, you can always, of course, try and it's a little bit easier now to try and roll your own. Because you can do a lot of it now in SQL itself. And then there's other vendors like Metaplane is actually one I've used as well. Metaplane's pretty cool. It's a little bit more focused on the data engineer and data ops side of the metrics, but you can kind of tweak some of these things to also cover business metrics as well.
And digging more into that concept of the business metrics and being able to generate alerts and detect when there are anomalies, I guess that's another vague term that might be worth digging further into, is that idea of anomalies and what makes something actually anomalous. Is it just because it is two standard deviations away from the mean? Is it because there's some specific rule that you have that this value can never exceed this threshold? I'm wondering, what are some of the specific types of anomalies that you're looking to address and alert on, and some of the ways that people need to be thinking about how to understand when something is actually anomalous versus just a little bit weird?
Yeah, that's a good point, and this is kind of I'm a little bit obsessed with anomaly detection, to be honest, because it's one of those areas of machine learning and data science that still has there's a lot of kind of art and science involved in it. So like there's a lot of subjective like decisions as to like, well, does this look anomalous to you? It does to me, and that there's still that sort of it's not as easy as like just doing something like regression or classification where you have a simple metric like accuracy. In anomaly detection, you don't have any metrics like this that you can use as a source of truth, so it's a little bit subjective. And so that's one of the reasons why we use good defaults basically. So we're using PyOD, which is an open source project around anomaly detection, and basically we have defaults there to use like as flexible a model by default as possible. So it's using best practice standard sensible things around feature pre-processing, and then it's using like a PCA based anomaly detection model, which is more flexible, and it'll cover more types of anomalies, as opposed to say if you just have single spikes. Okay, they're the obvious ones that people always think of, but sometimes there's basically like, instead of a single spike, is it a strange little squiggle that's changed recently, or is it an increase in trend, and a different wider kind of cast the net as wide as possible. And so that's why we're using PyOD with like a general flexible model underneath. But there's also then, of course, like if you're a user, you can define your own pre-processing function, or you can define your own model as well. So you can, if you wanted to, you can extend it to be like, maybe for instance, if it's say, well, okay, this metric here is daily sales, and you actually know that there's a big impact on whether it's the weekend or whether it's the weekday, say, or even time of day. So you could actually build your own pre-processing function to say, okay, I want to, like, when it's the weekend, I want it to be, is weekend equals 1, and then when it's during the week, is weekends equal 0, and you can then pass that through to the model to use that as a feature. So it can get quite sort of it can depend a lot on exactly how you want to do it. But the idea here with the Anomstack approach is to like use as general and sensible a default as possible that will cover all metrics reasonably well. And then if you want to kind of go more complex, you can. But yeah, it can get quite sort of subjective and complicated in terms of what is an anomaly or not.
Data projects are notoriously complex. With multiple stakeholders to manage across varying backgrounds and tool chains, even simple reports can become unwieldy to maintain. Miro is your single pane of glass where everyone can discover, track, and collaborate on your organization's data. I especially like the ability to combine your technical diagrams with data documentation and dependency mapping, allowing your data engineers and data consumers to communicate seamlessly about your projects. Find simplicity in your most complex projects with Miro. Your first 3 Miro boards are free when you sign up today at dataengineeringpodcast.com/Miro. That's 3 free boards at dataengineeringpodcast.com/MIRO. Digging now into the idea of metrics definition and identifying what are the metrics that you should care about, what are the metrics that are useful to be alerted on, what are some of the ways that data teams or operations teams should be approaching that question and thinking about, how do I decide what are the metrics that are actually going to matter, what are the ones that will give me a useful signal of something needs to be addressed and it's going to have some sort of business impact versus just, hey, it might be neat to know about this thing.
Yeah, yeah. It's typically what metrics are you reporting to your senior management? Basically, start with them. So there's typically like there's business metrics, where you start with. And typically they're obviously like headline business metrics like users, payments, sign-ins. Depending on your business, they're usually pretty obvious. The main bright stars. And then there's also like technical metrics as well. So we use sometimes a lot of technical metrics for like underneath the stuff for like the health of the app itself and things like that. But generally, it should be obvious, and if it's not obvious, then it's probably a question for, okay, well, maybe this isn't a metric I should use. Kind of the way I think about things though is that it's everything. Metrics are increasing. Everything has become a time series as we have more and more data, and metrics are becoming just more and more commonplace. So it's okay to have lots and lots of metrics. It's just that you want to have like a priority one level of metrics, priority two level of metrics. So you can kind of embrace the messiness of like, okay, we've got loads of metrics across all these other types of business, objectives, secondary objectives, but put them in a different bucket. Then you put your main kind of executive level metrics, and they obviously then would, they get a special route when they go off versus when all the other metrics go off, because then it's like, okay, well, if a P1 metric alerts, I want that to go straight into the Slack, or I want that to email me straight away. But then I also want like all the other metrics that are like lower priority or lower interest. Maybe every now and then I want to just open up that inbox and browse through those, kind of read the newspaper as such to see. And that's very useful as well then, because if you have a good anomaly detection system, it almost becomes like a BI tool in that sense as well, and that it's actually uncovering insights, and you can quickly. It's then more just about the UI UX. Like, can you quickly scan 50 alerts and see, oh, there's one thing there that it actually might be interesting. That's gold dust if you can get that in terms of an insight, because otherwise you would have had to pre-configure a dashboard, and maybe it's in some dashboard in the second tab and the third down the second quarter of the page, and you have to get so lucky that your eyeball happens to land on that chart. That's just, it's not really a scalable approach to analytics, especially in this day and age when there's just so much more data. So that's the other flip side of it as well. Is like, it's more about sort of how you make, how you route the insights that you get from these tools.
And before we dig too much further into the implementation of Anomstack, another thing that I noticed as I was reviewing the project is that you put in a lot of effort to make it as easy to get up and running and get started with and evaluate as possible, with including out-of-the-box pipelines for Dagster, having a GitHub code spaces available. I forget what the other options were, but it was just very much I really want you to use this thing. And I'm wondering, what was the impetus for putting in all of that effort, and what are some of the ways that that focus of making it easy to adopt, making it easy to test out, influenced the overall design of the project and the ways that you were thinking about how to architect it so that it was easy to adopt and implement?
Yeah, so my main kind of consideration there is to try and keep it like as easy as possible, in terms of like, it's not over engineered at all. Basically, under the hood, when you look into it, everything is like a pandas data frame that's moving around. So I kind of wanted it, basically built it for a version of myself maybe 10 years ago, who was like, instead of back then I had to like stand up my own Airflow VM and come up with like all the data engineering part of it. If I could actually just Docker compose up and then just focus on the SQL and the metrics, then I'd be really happy. And that's kind of what the aim is here, is that you can easily run through Docker, or even serverless. Dagster Cloud is really cool as well. The way they have an integration on GitHub, and it'll just automatically deploy to Dagster Cloud, so you don't even have any sort of operations. Then you can just focus on a PR to add new metrics, or as your metrics evolve. It's all kind of GitOps type approach. And the idea was there, like, ideally, I'd love to have. It's still quite early on in the project, so I've only been working on it kind of a month or two, and the plan is to kind of have users that actually use it, but could also then become contributors as well, and so lower the barrier to contribution as much as possible as well. So that's why we're kind of, all the concepts are very straightforward and very simple, and that's the idea, like, is to actually have users that can use it, and then also, like, if they want to make an improvement, for sure, like, yeah, get involved, make it pure, it'd be great. So that's the idea, is to actually have users and contributors.
In terms of the implementation, and as you were defining the scope of the project and thinking through, okay, I want to have this open source anomaly detection stack so that I don't have to rebuild it over and over again. What are the core capabilities and constraints that you were focused on that informed the final implementation of what you have built so far?
Yeah, so I actually originally started with an anomaly detection provider in Airflow. So we use Airflow, and I built a anomaly detection Airflow provider package that's also in the Airflow registry with the astronomer folks, and that works. So if you're using Airflow, that's one approach. But I was thinking as I was doing it, I was kind of thinking, well, this kind of depends on Airflow, and it's a bit silly for people to have to then stand up Airflow to do anomaly detection. So I wanted something that's more standalone. And so I also was aware, like at the time, that a lot of these data orchestration tools, there's so many options, and they're also like they're all great now. So the approach there was actually, okay, I want to have a flexible enough, general, simple orchestration tool, and then also use, PyOD does all the ML stuff. So it's basically putting all the ingredients together into this little app approach that's kind of fairly easy to stand up, fairly easy to reason about, and that's the main aim, is to actually have as little moving parts as possible, and just get what we need for decent enough, anomaly detection alerts into your inbox. That's the North Star.
And now, as far as the actual implementation, the architecture, wondering if you can describe how you implemented Anomstack and some of the ways that you optimized for these particular design constraints that you mentioned.
Yeah, so I had a look at a few different orchestration platforms basically, and it was a good excuse. I'd been aware of Dagster, but I hadn't really used it that much. I'd mostly been used to Airflow and other things like serverless options in GCP and AWS. And so I had a look at Dagster, and actually Dagster seemed almost perfect because the Dagster have an approach called software defined assets. That's like a really interesting approach that they have. But actually, a step underneath that is basically just jobs, and a job is the core kind of building block here. So when a user defines their metrics, a metric batch, basically, an Anomstack will just trigger 6 jobs, 4 main jobs. Like there's a job to ingest, a job to train, a job to score, and a job to alert. And so the main kind of concept here is you bring your configuration, and then the tool itself will do the orchestration, and then also use PyOD for the ML stuff as well. So like it's more mainly like putting together these recipes of different ingredients that are already out there in the ecosystem, and that's kind of what the culmination is.
From the time that you first started building this project to where you are now, I'm wondering what are some of the ways that the overall goals and implementation have evolved, and maybe some of the dead ends that you explored and ultimately discarded.
Yeah, I actually one of the dead ends that I almost thought was like it was kind of jokey, but we've implemented a LLM alert job itself. So instead of the PyOD ML models for the anomaly detection, we actually have an LLM alert job that you can enable, which basically just sends the data to GPT and asks it, does it look anomalous? And I was kind of more so curious because it's a good example of like where the limits are in terms of language models, because I wanted to see like how actually useful can it be, in getting sense back from the language model. And time series data is still a bit sort of at the edge of what LLMs are really able to do really well. So it was kind of fun playing around with that. There's a lot of iterations of doing like I started with as minimal approach as possible, send the data to the LLM, see what it gets back, and it was kind of it wasn't even kind of understanding the time series. Like it couldn't even get the order of the data itself. And so there's been a few iterations of that, like playing around with prompt engineering to actually give it all the hints it needs to do it. And it's kind of surprisingly working. But it works technically, but like it works and it makes sense. But when you look at it then and take a higher picture as a human, it's actually not that useful at all, because the anomalies that the LLM comes up with are technically, often they are anomalies, but they're not anomalies that you would care as a human if you're eyeballing the data. And so it's tricky. That was like, it was fun to do all that, and I kind of mainly did that just as a sort of a joke almost. But that was something that I think is it's kind of interesting to see, but it's being definitely I've just turned them all off today by default. It's an optional kind of job that you can turn on. It's a little bit of a dead end. I don't think it's as useful as you might think it is.
For people who are interested in testing it out, getting it deployed, as we already discussed, there is a very easy on ramp. But for people who want to then go from, okay, I've tested it out, it seems interesting, now I want to run it in production, what does that journey look like? And what are some of the considerations and potential sharp edges that people need to be thinking about as they go from proof of concept to this is business critical now?
So there's a couple of ways to use it. The repository itself is a GitHub template, so you can kind of actually you can clone. You can obviously of course clone the repository, but you can use the GitHub template to make a copy of it, and then once you have that GitHub template repository, you can then use that for your metrics and deploy it however you want through Dagster Cloud or just using your own kind of CI/CD and Docker Compose. So some of the sharp edges are probably like this. It's still very immature project. It's still very very young. I just finished like the first set of proper tests today. So there's always like this is something that comes with these open source projects as well, is that it's especially when they're young like this, that definitely is. I wouldn't. It's a pinch of salt in terms of like it's better. You're better off like dog food it gently on stuff that's not production, and then once you're comfortable with that, then you go from there. So like that's what I'm doing at the moment. I'm kind of dog fooding it as we go, and so there's a little bit like there's a small little bit of infrastructure in terms of, okay, how are you going to run these Docker containers, how are you going to monitor them, how are you going to have availability, things like that. These are typical enough kind of considerations with tools like this. So there is still a couple of kind of, it's not completely hands free, it's not completely painless, not yet, but the aim is to be as painless as possible basically. And so there's definitely some typical kind of sharp edges there in terms of like, we don't have necessarily a standard deployment or standard installation. Yeah, we've given as many as possible, so you can use Docker, or you can use a local Python environment yourself, or you can then use the serverless options as well. And so we're kind of waiting to see which approaches people are most comfortable with as well.
Data lakes are notoriously complex. For data engineers who battle to build and scale high-quality data workflows on the data lake, Starburst powers petabyte-scale SQL analytics fast, at a fraction of the cost of traditional methods, so that you can meet all of your data needs, ranging from AI to data applications to complete analytics. Trusted by teams of all sizes, including Comcast and DoorDash, Starburst is a data lake analytics platform that delivers the adaptability and flexibility a lakehouse ecosystem promises. And Starburst does all of this on an open architecture, with first-class support for Apache Iceberg, Delta Lake, and Hoodie, so you always maintain ownership of your data. Want to see Starburst in action? Go to dataengineeringpodcast.com/starburst and get $500 in credits to try Starburst Galaxy today, the easiest and fastest way to get started using Trino. There are multiple different flavors of open source projects where sometimes people just want to produce something out in the open, but they don't really care about getting contributions. There's the corporate open source where we're going to release this because it furthers our business, and if you happen to get use out of it, that's great. And then there are the open source projects that are intended to be maintained and grown by a community. And I'm wondering what your thoughts are on how you're approaching this particular project. Are you looking for contributions? Are you just looking for feedback? I'm wondering what types of engagement and community you're looking to build around it in ways that folks can contribute and help you out with this.
Yeah, no, I'm always looking for contributions. I would love some contributions. Kind of, I don't necessarily have like a software engineering background myself, so that's always been sort of a fear I've had around the imposter syndrome and stuff like that. So I would love if somebody came with a contribution that completely showed me, oh, your tests are all wrong, or you could do something better, or like here's better abstractions we can use. There's definitely like room for improvement across the board. And so I'd love contributions, and that's been the aim of like keeping it as simple as possible, where everything is basically, all the main concepts are, you have like a metric batch, which is just a definition of your metrics, and then you have jobs, which are like ingest, train, score, alert, and then within under the hood, when you're looking at the code, really it relies heavily on pandas data frames. Every job basically produces a pandas data frame, or it takes in a pandas data frame and produces a pandas data frame, so it's quite easy to reason about. And so that's the idea, is that like if you're someone that's a comfortable enough in Python developer, like it's a perfect project to do first open source contributions on as well, which would be really fun. Like,
And for people who are looking to get engaged with the project and maybe they don't necessarily want to modify the core of what you're building, but they are interested in extending or augmenting its capabilities, what are some of the interfaces that you've built in to make it open for extension and customization and adapting to a particular customer or operating environment?
Yeah, so that was a good example of where I haven't tried to be too complicated from the start. So obviously we support BigQuery, Snowflake, DuckDB, a couple of other databases. And I was thinking like, okay, do I need to build some fancy plugin architecture or plugin system where somebody could bring their own plugin? And I decided not to do that because probably it's at the edge of my capability, but also it makes it harder to contribute on as well. So the approach would be at the moment, for example, I'm working on Redshift at the moment and adding Azure Blob Storage. Um, just make a fork, make a PR, and it's everything's kind of easily testable. And so that's where we haven't gone. It's not as complicated yet in terms of like taking, say, something like the Airflow approach where you have plugins that you can install separately, dependencies and stuff like that. We haven't kind of we're not it's not sort of taking that approach yet, mainly for that goal to have like the as low a barrier as possible to contribution. But definitely at some stage, if the project does become more mature and stuff like that, then yeah, like that would be something that I would imagine would be refactored at some stage.
Digging more into the I'm using this, I'm running it, I want to feed in these different metrics. You mentioned that it has support for pulling from databases, running Python scripts. I'm wondering if you can talk a little bit more about the process of producing the metrics that Anomstack is going to work from and the overall flow of data in, evaluation, alert out, or, ignore because there's nothing to alert on.
Yeah, yeah. So like the main approach there, the inputs are there's a metrics folder basically in the root of the project, and within the metrics folder, then you can have a folder for each subject area or each metric batch, or you can kind of do you can organize the metrics however you want as long as they're underneath the metrics folder, and all a metric batch is some ingest SQL. So there's a template that you just define an ingest SQL file, which is basically just some whatever SQL you want to use to generate your metrics. And so basically, this is SQL that generates a table which just has a metric name, a metric value, and a metric timestamp. There, that's all that's required. So, and once you have that, then that's the ingest. That's the basis for the ingestion. And then there's also then a YAML configuration file, and the YAML configuration file has all the other things like schedules and parameters for the models. And again, you don't have to fill any of them. You can kind of just leave that file pretty much empty, and it'll use the defaults. There's also like a defaults YAML that you can edit your defaults as well. So the idea is you just bring your ingest logic basically, and you can use a SQL. You can use an ingest SQL function, or you can actually, if you want, you can also use your own. You can make a custom Python function. So all you have to define if you're doing something that's maybe, say, you're scraping metrics from a website or from something public, metrics, or even doesn't, if it could be anywhere. But if it's a Python function, you can then also just use it. You can just bring your own Python function, as long as that Python function generates a pandas data frame that then has those same three columns: metric name, metric value, metric timestamp. That works as well. So we have loads of examples in the repository that do that. Like there's examples that pull metrics from Hacker News and weather metrics and Yahoo Finance and all that sort of stuff. And once you have that, then you can customize anything under the hood. There's default templates. So like there's a default template for the pre-processing function that the ML uses. You don't ever have to worry about that, but if you want to, you can bring your own for each individual metric batch. Likewise for the alert logic, you can also define your own alert SQL template if you want, or you can edit the default one that's there. So the idea is once you bring your ingest logic and your configuration, then that will trigger off everything. So the ingest jobs, the train jobs, the score jobs, and then all that's happening behind the scenes is it's going to kind of run that ingest script, save the results onto a metrics table, and as it's doing the scoring, it'll also save the scores onto the metrics table, and as it's doing the alerts, it'll also save the alerts onto the metrics table. So this all then just becomes kind of orchestration that's reading to and writing from this metrics table in your warehouse, basically, which could be Snowflake, BigQuery, whatever. And this is like a long format metrics table where each row is basically a new metric. So it's kind of easy to think about as well, because as you add new metric batches, you're just appending onto the end of that table. Or you can, of course, also have, like, if you want, you could have different metric metric batches going to different metrics tables. That's all flexible, but it's easiest to think about just having like one start with one single metrics table that Anomstack is reading from and writing to, and that kind of becomes then that's the heart of what's going on here basically. And you can plug that into your own tools as well. So if you have your own BI tools or your own alert tools or anything like that, that then it's just another table in your data warehouse, so you can kind of use it like anything else basically.
And recognizing that it's still a very early project, that you are still working on gaining visibility and getting feedback, I'm wondering, what are some of the most interesting or innovative or unexpected ways that you've seen Anomstack used so far?
Well, I was a couple of weeks back. Actually, I was happy enough. So one of the examples we use in the examples, out of the box examples, is like a Hacker News. It scrapes the top, the scores from the Hacker News top stories. Every. And I was like, as soon as all the Sam Altman drama with OpenAI kicked off, I was kind of crossing my fingers, thinking, "Oh my God, this has to now get picked up. If this isn't picked up but in the example job, I'll be kind of have egg on my face." And funny enough, I have. It was as soon as all that kicked off, Hacker News exploded, and I had Anomaly straight away from the Hacker News jobs, and I've put them into the gallery. There's a little gallery folder in the repository as well that has examples of like real anomalies that I've been using it on real data. And there's a Sam Altman fired HN explodes.png in there as well. I was happy to have. But that was like it's interesting as well. Just recently with sort of we're also looking at stock prices and stuff as well, like just trying to get a wide range of as many examples as possible to get like realistic data. And just the other day I noticed all of the tech stocks were down a couple of points based on the Yahoo Finance job, and then I actually googled it and I was like, yeah, actually they are all closed. I thought there was a problem with I thought something was going wrong somewhere, but actually no, it was valid.
That's an interesting use case as well, where maybe it's not business metrics that you care about. Maybe it's just personal curiosities, and you can build your own sort of Google Trends style alerting of, hey, I want to know if something changes in this particular ecosystem. As long as there's some sort of API you can hit, then you can build your own personal anomaly dashboard about what are the anomalous things happening in the world today.
Yeah, no, and that's actually Google Trends is another example. We have a Google Trends example as well. So I'm kind of constantly building out this examples folder within the metrics folder, so that you can turn them off as well. Like, so you can, but they're useful to kind of be realistic types of examples that people can look at as well.
Yeah, it's definitely a very cool project in that way, where, as you mentioned, there are anomaly detection tools. A lot of times, though, they're very coupled to the product that they're trying to generate the alerts from. So Datadog has some anomaly detection. I know that the Grafana Cloud product has some ML capabilities for alerting on anomalies, but again, all of those are very tightly coupled to the ecosystem that they're built for, whereas this is a little bit more open-ended of, as long as you can get data somewhere, we can let you know if something is weird.
Yeah, and that was almost as well one of the kind of design principles here was to have no UI and have like it's all basically config based and GitOps based, so that it's what we're used to working in as like data engineers, and it's lower overhead. We don't have some crazy management UI and admin console where you have to go and click around and configure stuff. It's all kind of your metrics as code basically, and everything as code, and that kind of helps make it easier to if you want to add new metrics, it's just a PR and then no problem.
Absolutely. And in your experience of building this project, publishing it to the community, looking for feedback, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
So it's been fun actually learning. I had to learn kind of quite a lot about Dagster, so because Dagster is really at the heart of it, doing all the orchestration. So I had to go quite deep in terms of getting familiar with even some edge cases and stuff around how Dagster works, and all different configurations to be able to support like running locally in your own Docker versus Dagster Cloud versus a Python environment. There's a few different kind of considerations there. So that's kind of been fun and being like interesting to kind of start from new with a new technology. It's always fun, especially all these modern data stacks technologies. It's overwhelming. Like there's so many of them that it's almost scary. It's almost too much sometimes, and you kind of just turn on the blinkers. So, but it's been good to have an excuse to actually then just pick one and use it and go with it has been useful. And yeah, also as well, just my own capabilities. I would say actually I should preface like probably another part of it, like projects like this are now actually easy to do because we have all these tools that we can use, and once you kind of know enough to put the ingredients together, I've also been using, Copilot and ChatGPT to help a lot with the code as well. Like it's crazy how much more productive you can be these days, especially with an open source project like this, where it's like you can develop fully in the open. You don't have to be worried about, anything confidential or anything like that. It's you're just unconstrained to actually use these tools. And yeah, it's been, like, I'd say probably 30% of the code in parts has been at least inspired by Copilot and like ChatGPT. So that's been really interesting, because it's like when you used to ask for help on Stack Overflow, you have to spend a lot of time, reproducible examples, and ask the question in the right way and show your work and things like that. Same thing applies for the language models, and once you do that, they can actually be ridiculously useful. So it hasn't been half as much work as I thought it would be, because we have all the tools that we're using are quite easy to work with. And then, like, this assistive, Copilot type approach, it just means, if I have an idea, I can make an idea and then spec the idea out and actually get it done, probably, in half the time that it would have taken originally. So that just means you've got more time, you can get more done with the amount of time you can focus on a project like this. You can just get so much more done for it.
And for people who are interested in Anomstack, they want to start to incorporate some measure of anomaly detection on their business metrics. What are the cases where it's the wrong choice?
Yeah, so I think probably the main cases there would be if it's like low latency, per second. Like, that's some of the stuff that we've done with net data. It's all infrastructure per second metrics, thousands of metrics a second. That's a completely different domain where you have, like, just different design challenges. And so a non-stack wouldn't be right for anything like that. It's more typically like, hourly metrics. I mean, I do have like 10-minute metrics and things like that. But anything below, anything too near real time, it wouldn't make sense. And a situation like that, you're in more of a data observability situation where you, like, things like Prometheus and sorts would be more useful, and InfluxDB, say. But the other use case would be, I guess, if you have scale, like if you've got thousands and thousands and thousands of metrics. I'm not sure how well that would happen. How well, say, a Dagster running in a container, how well that would scale to if we had like hundreds and hundreds of metric batches. I reckon there's probably that would be a nice problem to have if we ever get that far. We have that problem, but I would say that's probably another issue where I'd say it's not right for you. And then also, like, if you're not comfortable enough with sort of running a Docker app, basically, then it's a good excuse to learn. It's a good chance to kind of get your hands dirty, and it's not as painful as, like, things used to be. But also, that's something that, like, there's a little bit of consideration there in terms of, like, are you comfortable enough running this yourself? Or obviously, like, you can use the Dagster Cloud. If you have a Dagster Cloud account, that works as well. But yeah, I'd say situations like that, I'd say it's probably not quite the right option. Also, if you're using Airflow, if you already have an Airflow, you should probably look at the Airflow anomaly detection provider, which is a different project that I maintain. That would be really cool to get some love in there at the moment as well, because that one I've only really set it up for BigQuery, but obviously there's all the different type of operators, and all this stuff already exists in Airflow, so it's not that hard to actually use them. It's just if somebody's motivated to come and use it, then they might be as well to actually use your own Airflow that you already have.
And as you continue to build and iterate on the Anomstack project, as you work to onboard more contributors, what are some of the things you have planned for the near to medium term, or any particular projects you're excited to dig into?
Yeah, so there's a couple of open issues in the repository of ideas, and I'm just kind of throwing issues in all the time. And one thing I want to do, I have a feature request open for Time GPT. So in still kind of shaking out these LLM approaches, there's Time GPT, which is a new sort of time series friendly large language model, and I'm hoping to see if I can it's still sort of in a closed beta, so I'm hoping to get access to that to actually see if we can use that, so that might actually be more useful. And then also, just there's a few things around wanting to let the user run multiple models. So, like, at the moment, it's for each metric you define one model, and the default model is this PCA based model. But actually, really, maybe you want to define like three or four different models, and actually just let them run for a week or two, and then you can actually see, okay, as the metric comes in, how do the anomaly scores behave, and which ones work best for this metric. So there's definitely a whole load of stuff where we could make the ML part of this easier as well, I think. So if you could run multiple models and then over time pick them, that would be good. Or if we could do some sort of way where you could benchmark and simulate your metrics on different models, that could help with the ML parts. I think that could be really useful as well, because that's always the challenge. Is like, it's very hard. There is no one size fits all model, and it can sometimes take a bit of iteration as well. So if we could take the pain out of some of that, that could be really useful as well, and kind of fun to work on as well.
And given the time series nature of the data, it might also be interesting to bring in some sort of time series predictive capability, whether that's using the Profit library or I think there's another one, Gray Kite. There are a number of them out there now to say this is the current trend line. If this continues, then this will maybe then trigger an anomaly, and so here's some kind of preemptive alerting of something to keep an eye out for.
Yeah, yeah, and there's lots of other concepts on ML that we could bring into this in terms of like forecasting is an obvious one as well, but then there's also like change detection is another one where sometimes what you're interested in is a sudden change, even if it's not an anomaly. Like maybe sudden changes happen, they happen every time, but they're not going to be flagged as anomalous because the ML is going to look at those shifts as like, oh well, steps happen every now and then. But actually, if you have a real focused area where you're interested in, okay, what happened last night, something went wrong, what you really want to ask a lot of times there is, okay, change detection, show me the metrics that had a sudden change. And that's like a different use case where it's like a subset of it's like a subset of anomaly detection. It's not quite a little bit different. And so there's all these other kind of little ML time series based, ML use cases that we could for sure build in like over time. That would be interesting.
Are there any other aspects of the Anomstack project or this overall space of business metrics and anomaly detection that we didn't discuss yet that you'd like to cover before we close out the show?
No, no. Just I definitely think it's an interesting time, especially like as we can, there's a lot of the modern data stack. There's lots of stuff going on. It's crazy. It's overwhelming. But I do think technology is catching up. In terms of actually the metadata and making sense of making sense of what's going on in your data. That's like the hard part. We have all the plumbing. We have all the flows. We have all the details. It's just how do you actually make sense of like what things matter the most. That's still a sort of an open problem that I think with now like a lot of these kind of AI. I won't say that's the first time I think I've said AI. I hate saying I cringe every time I say AI, but actually this is one case where like it actually will I think really be useful over the next couple of years and like making sense of all of the crazy business metrics and data that companies have.
All right. Well, for anybody who wants to get in touch with you and follow along with the work that you're doing or contribute to the project, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
I think possibly the biggest gap is just the complexity of the space. There's still a I'm not sure where I sit on this as well. So there's point solutions that kind of focus on one thing and do one thing well, and then there's all these platform options. And I think that's the biggest complication now is just navigating the space in terms of how do you compose things together. There's still like there's work on standards and stuff like open lineage and all these kind of standards that are trying to become a glue for all these different solutions. But I think that's the biggest challenge is actually like how do you actually just put things together and or do you actually try and go like just a big cloud provider and just use whatever they have. That's probably the biggest gap I see.
Absolutely. All right. Well, thank you very much for taking the time today to join me and share the work that you've been doing on the Anomstack project and for building it in the first place. It's definitely a very cool project. Definitely excited to try that out for my own data platform and explore the possibilities that opens up. So I appreciate all the time and energy you've put into that and for taking the time today. And I hope you enjoy the rest of your day.
Thanks a lot for having me on. I'm a big fan of the show, and anyone else who's interested, just come check out the repo and
Question,
make
I'd
some
like to
issues,
get
make
your
some
perspective
discussions.
on what
I
you
will
see as
be
being the
delighted to
biggest
have
gap in the tooling
people
or
come along and say
technology
hi.
that's available for data management today.
I think possibly the biggest gap is just the complexity of the space. There's still a I'm not sure where I sit on this as well. So there's point solutions that kind of focus on one thing and do one thing well, and then there's all these platform options. And I think that's the biggest complication now is just navigating the space in terms of how do you compose things together. There's still like there's work on standards and stuff like open lineage and all these kind of standards that are trying to become a glue for all these different solutions. But I think that's the biggest challenge is actually like how do you actually just put things together and or do you actually try and go like just a big cloud provider and just use whatever they have. That's probably the biggest gap I see.
Absolutely. All right. Well, thank you very much for taking the time today to join me and share the work that you've been doing on the Anomstack project and for building it in the first place. It's definitely a very cool project. Definitely excited to try that out for my own data platform and explore the possibilities that opens up. So I appreciate all the time and energy you've put into that and for taking the time today. And I hope you enjoy the rest of your day.
Thanks a lot for having me on. I'm a big fan of the show, and anyone else who's interested, just come check out the repo and make some issues, make some discussions. I will be delighted to have people come along and say hi.
Thank you for listening. Don't forget to check out our other shows, Podcast.init, which covers the Python language, its community, and the innovative ways it is being used, and the Machine Learning Podcast, which helps you go from idea to production with machine learning. Visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.